A 6 feet tall basketball player shoots the basketball 15 feet away from a 10 feet basket with 2.13 seconds left on the clock. He notices that the shot went in the basket as the timer hit 0 seconds. At what angle relative to the horizontal axis did he shoot the ball? Assume projectile motion and that he released the ball from the top of his head. Neglect air resistance.
I started the problem off by drawing a figure so that I could visualize it. So the basketball player is going to shoot essentially from 0-0 to 15-4 because he's 15 feet away from the basket and he's 6 feet tall and the rim is 10 feet high. So the difference between him and the rim is 4 feet. And then obviously you want to convert from feet to meters. I already did it. I didn't show the stoichiometry though. And from that, you can deduce that this is the kinematics equation to use because this is the only one that uses position. And in the problem, all you are given is position and not velocity. And we will use these two once we start doing the problem. I put two things to remember. At t equals 2.13, the coordinates are as stated right there. And the acceleration for gravity is 9.8. First, you want to plug in all the values. Like this is for the horizontal axis and this is for the vertical axis. And once you plug everything in for the y-axis, you want to solve for this right here. You want to move this to this side, and I'll tell you why. So once you get this conversion factor, you want to plug those into the v naught x. So it says v naught x equals v naught cosine of theta. Once you plug that in, you'll get these on both sides. And now what you can do is you can divide the 23.449 by 4.572. You can divide this side by v naught cosine of theta times 2.13. You can do this because previously you established that 4.572 equals v naught times cosine of theta times 2.13. And now what you can do is you can get rid of this and the v naught, and then you have 5.119 equals sine of theta over cosine of theta. And as you might remember, sine theta over cosine of theta equals tan theta. So you get the inverse tangent, which equals 5.119, and then you can solve for that and you should get 78.9 degrees.
Here are a few common mistakes or misconceptions that may arise while solving this problem. 1. You may forget to convert feet into the SI units of meters. Neglecting to do so will mess up the whole problem because you absolutely need meters in order to use kinematics equations. 2. You may have been thrown off by the fact that the basketball player is 6 feet tall, whereas the actual basket is up at 10 feet. When you are doing the calculation, you need to take this into account and subtract the 6 feet from the 10 feet, which is the vertical distance between the top of the player and the hoop. 3. Remember that in order to do kinematics equations, there cannot be acceleration in the x direction. Thus, the only acceleration in the problem is the vertical acceleration due to gravity. Also, number 4, treat each axis separately. You cannot combine kinematics equations for both the y and x axis because the accelerations, velocities, and displacements are not the same. You may, however, use the same time.